I kind of previewed this for you. We have talked about, and you guys did it in your board race there at the start. We talked about how to square binomials, and the only other thing we're going to do with them as far as increasing the power is we're going to take binomials to the third power. So if you remember yesterday, we talked about this at the end, about how we're still going to...
Randolph to the front desk for early dismissal, please. Thank you.
Sorry about that. Okay, so, Christiana, would you mind getting your notes out, please? 5.6, 5.7, 5.8 is where we're at. So the first step here would be to expand x minus 2 cubed into what it really means. What it really means is x minus 2 times x minus 2 times x minus 2. And now you have a choice about how you want to approach this, but it really makes very little difference. So I hope that you guys, if you haven't already written this down, I hope that you're writing this down with me. That's what we did yesterday at the end, but we'll get into some finishing stuff with this here in a second. I'm going to choose to multiply the first two binomials together first. And to do that, what do I need to use? FOIL. So I'm going to FOIL, just like you guys have been practicing a lot lately. So I'm going to FOIL here, and I'm going to get x squared minus 2x minus 2x plus 4. And we want to remember that that is still being multiplied times x minus 2. So like with most FOILs, the middle terms can be combined. And so when you combine the middle terms, what do you get? Yeah, that's right. So it'd be x squared minus 4x plus 4. We still have x minus 2. This is about where we finished yesterday. In order to complete this, we need to multiply. Let me ask you guys this. What kind of a polynomial is the first factor? Trinomial. And the second one is? Binomial. So we have a trinomial times a binomial. So one of the ways to simplify this would be to take each term of the binomial and distribute it to each term of the trinomial. Do the same thing with the negative 2 there. So that's the approach that I'm going to take. So when I do that, I'm going to do these first. So it's going to be x times x squared, which is x cubed. X times negative 4x, which is minus 4x squared. And x times 4, which is plus 4x. Next, I'm going to distribute the 2. So I'll do this series of distributive property. So negative 2 times x squared is minus 2x squared. Negative 2 times negative 4x is plus 8x. And finally, negative 2 times 4 is negative 8. So my final answer, if I combine my like terms, will be x cubed minus 6x squared plus 12x minus 8. So x minus 2 cubed, steps are pretty straightforward, but it takes quite a bit of space and a decent amount of time too. Please be really, really careful with those. I know you can do it, just be careful with them for sure. Okay, any questions on that one? No questions? Okay, so we're going to do one more kind of a typical question, and then we're going to do some, I don't know, some slightly different stuff to finish things off. So take a look at number 6 before we, here we go. So this says simplifying expressions with polynomial multiplication. So these tend to be, like what we're going to do with 6, 7, and 8, these just tend to be combinations of stuff. So when you guys look at a problem like number 6, we're supposed to simplify this completely. What do you see as you just kind of survey this and look at what kind of polynomials we have, what's going on? Does anything jump out to you as something that we should do? Sam? Yeah. I agree. I see 2 sets of distributive properties as well. I think that's a wise choice. So I'm going to show these distributive property rainbow things, and I think we should do exactly what Sam has suggested. So I'll do that up here. That would give us negative 6w squared plus 12w minus 6. And then be very careful that you distribute the negative sign in the second one. So that would be minus 8w squared minus 4w plus 20. Still doing good? Now what's left for us to do? Yeah, simplify by doing what? There's a bunch of like terms, right? So what is like negative 6w squared? Yep, and when you combine those, you get what? Yep, negative 14w squared is right. And then 12w, what is like 12w? Combine those, what do you get?
8w.
Yep, so plus 8w. And finally, the negative 6 and the 20 are like terms, so plus 14 would be how we finish that. Okay, questions? Okay, so I hope this next piece is fun for you. With you here on this one, and we'll do this for our video as well. So number 7. Well, hold on. We haven't even decided if anybody got it right or wrong yet.
We erased our answer.
Just hold patience. Here we go. You guys, a lot of you folks were asking, how is it this? Why is it that? Is it all correct? I see 2 answers that agree, and it looks like maybe she's coming up with the same answer. Okay. So here we go. What do you guys see over here on the left?
Binomial times a binomial.
Binomial times binomial always means we should FOIL. So let's do that.
Turns out
So-
binomial times a binomial if you distribute.
So a squared minus 3a minus 2a plus 6. And then what do you guys see over here on the right?
Binomial times a monomial.
And what property do we use for that?
Just distribute.
You guys said distributive property, so we're going to attempt to do that. So when I distribute, I get plus 3a squared plus 30a. Once I get down to this, it comes down to adding some like terms. So there's quite a bit of it going on. So a squared and 3a squared are like terms, so 4a squared. So I think I agree so far with you guys. 4a squared seems like a good first term. And then let's see here, I've got negative 3a, negative 2a, and positive 30a. So yeah, I think plus 25a when you add those like terms up makes sense. And then the only one left is a 6. So plus 6. Y'all agree? We good? Okay, awesome. So, any follow-up questions from anybody? Okay, awesome. So let's move. We go. All right, so let's make sure we're all clear on the steps. For the first time, there's some differences in answers. So what do you guys see happening right here on the left?
On the far, that left? Or
The one that I just
oh,
underlined. Sorry, up there.
Oh, okay.
It's a binomial times a binomial. So we need to expand that, right?
Yes.
So maybe that would be a good first step, is just to write it out for what it is. It's really 4d minus 3 times 4d minus 3 minus... What do you guys see happening in that second set of parentheses? It's a FOIL, right? It's a binomial times a binomial. So when I FOIL, it's going to be d squared minus or plus 9d minus 9d minus 81. On the left, I'll FOIL that. So it's going to be 16d squared minus 12d minus 12d plus 9. I'm going to distribute that minus sign throughout these parentheses. So that's going to be minus d squared minus 9d plus 9d plus 81.
We did it wrong. I think
Okay.
everybody got it wrong.
Right, guys.
So 16d squared and negative d squared, those are like terms, aren't they? So I would say those would add up to be 15d squared. As far as our other like terms, negative 12d, negative 12d, negative 9d, and positive 9d, those are all like terms. But wouldn't the negative 9d and the positive 9d add out?
Yeah.
Those would just add up to be 0. So it really comes down to minus 24d. Okay? And then finally, 9 plus 81 is 90. And so I would say that Team 20.0, I agree with you. Nicely done. Looks like the only thing, there's 2 things we disagree on, right? with our other two teams here, we got the minus 72 versus the 90. So it looks like you guys forgot to distribute that negative all the way to the negative 81. And then, you know what, it looks like you guys just did not distribute the negative sign at all, right?
Yeah.
No, we distributed, we just did it before.
No, you distributed it to the D minus 9 and the D plus 9. It should only go to one of them.
It needs to only go to one of them. Rocky's right. If you do it to both, then you're effectively multiplying by 1 instead of negative 1.
Yeah.
So yeah, Rocky's right on that. That makes sense. Okay, nice job. Nice job. You guys have any questions? All right, ladies, hey, nice job. Way to go. That was well done. I think the teamwork thing is should be played up more, right? We should be working together as much as possible. So hopefully that's a good thing for you. We're going to do one more, and then I think it's good to revisit this. It says find a polynomial for the area. So we're talking about the area. It's a triangle. Does anybody remember the area formula for a triangle? Divided by 2, sure. So area is equal to base times height divided by 2. Is it okay with you if I write it as 1/2
Yeah.
times base times height? I'll make it a little bit easier. That'll make it not a fraction for the whole thing. Okay, so the base and the height are listed up there as 4x plus 6 and 4x minus 6. So for our triangle here, we're going to write area equals 1/2 times 4x plus 6 times 4x minus 6. The two polynomials are what types of polynomials? They're binomials, that's right. And so when you're multiplying two binomials together, we FOIL. So 4x times 4x is 16x squared.
I forgot the last part.
Forgot which part?
No,
Oh. And then outers is going to give you minus 24x. The product of the inners will be plus 24x. And then finally, the product of the lasts will be minus 36. I'll clean it up on the inside there a little bit. So area equals 1/2 times 16x squared. The two middle terms add out completely. So it will just be minus 36. And my final step would then be to distribute that 1/2 by multiplication. So I'm going to end up with 8x squared minus 18.
Why wouldn't it just be 8x? Why is it 8x squared? Why isn't it just 8x?
Okay. Well, so where the squared came from is when you multiplied your firsts. So 4x times 4x would be 16x squared, right? So that's where the squared first showed up.
Yeah, but when you divide, when you
Yeah, but if you, so I think what Rocky's trying to get at here is if you divide everything by 1/2, the 16 and the negative 36, wouldn't you also divide the exponents?
No.
No? Why?
It's not how it numerically works out. I'll show you. Can I use some numbers to explain why?
find the
Go
area.
ahead.
Because we're trying to find the area.
You're inviting me to go ahead, huh, Jake?
Oh, yeah.
Okay. So Rocky, Jake, others might be interested in this. Let me show you. I think what we're talking about. Let's do something with numbers that are pretty easy to work with. Let's do 1/2 times 4 times 3 squared. Right? This will be exactly like what you're talking about, right? Does that make sense, Rocky? Okay, so what you're proposing is that we do 1/2 of 4 is 2, and 1/2 of 3 squared is 3.
Oh, I get it now. Yeah.
So that would be 6. But if we follow order of operations, here's what you'd really do. You do exponents first, so that would be 1/2 times 4 times 9. And then 1/2 of 4 is 2 times 9 is 18. So following order of operations, we know that that's good. This was a question mark, and since these two answers don't agree, this must not be good. There's other reasons for it, but I like the practical side of it is like, hey, does it work? I think I just showed where it does not.
Yeah, I see where that would be. Yeah.
But so I guess
Makes sense.
a counter, kind of a counter argument, Rocky, would be this: like if you have something like 5x squared plus 10x, and then you're multiplying by, I don't know, like 3. I don't think that at any point we would have said, well, that's 15x to the 6th plus 30x to the 3rd or something like that, right? We would not have said that. Here, Rocky, here's another way to think about it. We will never, and saying never is a bold thing, right? Because that just says that there's no exceptions to this. And I'm pretty sure there's no exception to this. We should never, ever, ever multiply a base times an exponent.
Okay, so.
Never multiply a base times an exponent.
So another thing that I thought of